My name is Jacob Pushy, and today I'll be discussing with you the Week 7 Advanced Concept presentation, which asks me to research the drug lovastatin and walk you, the audience, through the cholesterol biosynthesis and how lovastatin inhibits high cholesterol. And lastly, I will discuss if lovastatin goes through any structural changes before becoming active. So firstly, to understand how lovastatin inhibits high cholesterol, we must first understand how cholesterol is synthesized. So cholesterol lacks a long hydrocarbon chain, which is characteristic of triacylglycerol and membrane lipids. In addition, cholesterol maintains proper fluidity of cell membranes and is a precursor to steroid hormones. And all 27 carbon atoms of cholesterol are synthesized by acetyl-CoA in 3 stages, in a 3-stage synthetic process. So stage 1 is the synthesis of isopentyl pyrophosphate, and that occurs in the cytoplasm. And then stage 2 and 3 both occur in the lumen of the endoplasmic reticulum, and stage 2 is the formation of squalene, and then stage 3 is the conversion of squalene into cholesterol. So stage 1, the synthesis of isopentyl pyrophosphate. So this is the synthesis of mevalonate, which initiates the synthesis of cholesterol, and mevalonate is converted to 3-isopentyl pyrophosphate, so the synthesis of isopentyl phosphate. And then stage 2 is the formation of squalene. So squalene, or C30, is synthesized from 6 molecules of isopentyl C5. So it goes C5, C10, C15, and then finally C30, squalene. So the formation of squalene in that stage 2. And then lastly, the conversion into cholesterol is stage 3. So squalene cyclizes to form a ring-like structure, and that is the final conversion in that ring-like structure to form cholesterol out of squalene. So, now that you understand the 3 steps and how cholesterol is synthesized, what is lovastatin? So lovastatin is an inactive lactone, and it is hydrolyzed to the corresponding beta-hydroxy acid form in our stomachs. So part of a class of compounds called statins, a drug class called statins, and in addition, it is specifically an HMG-CoA reductase inhibitor. And then also another name for a brand name is Mevacor. Lovastatin inhibits fatty acid synthesis and is responsible for cholesterol lowering. So lovastatin is structurally similar to HMG, which is why it's an HMG-CoA reductase inhibitor. And that HMG is a substituent of the endogenous substrate of HMG-CoA reductase, which makes it an inhibitor of such. Lovastatin is a prodrug that is activated in vivo, so in life, in us, via hydrolysis of the lactone ring to form the beta-hydroxy acid. So the hydrolyzed lactone ring mimics the tetrahedral intermediate produced by reductase, which allows the agent to bind to HMG-CoA reductase, thus inhibiting it, with 20,000 times greater affinity than the natural substrate. So, the bicyclic portion of lovastatin binds to coenzyme A portion of the active site, and that is how that occurs. To recap, it's a prodrug that activates in our body via hydrolysis of the lactone ring to form the beta-hydroxy acid. The hydrolyzed lactone ring mimics the tetrahedral intermediate produced by the reductase, which allows the agent to bind to HMG-CoA with much higher affinity than the natural substrate, and thereby inhibiting lipid formation. So that is my presentation on my research on the drug lovastatin and a walkthrough of the cholesterol biosynthesis and how lovastatin inhibits high cholesterol, and lastly, if lovastatin goes through any structural changes before becoming active. Thanks, guys.